Hi SRPs, how are you all? I think this is our first video in 2022, right? So I wish you Happy New Year to you all, and I again wish you and your family a safe Happy New Year, because as we know our new guest Omicron is with us, right? So be careful. So in our part 1 video of the complex number 6b exercise, we have already solved the question from 1 to 15. If you have still have not solved, go to the link I have given in the description. First, solve the question number 1 to question number 15, and I have given all the required concepts there. Okay, so you will not feel the difficulty. So first solve the question number 1 to 15, then come to this video. But if you have already solved from 1 to 15, so let's begin the class here. And in this video, we are going to solve the question from 16 to 29. So, are you all ready with your pen and paper? So, let's begin the class. Students, question number 16 is in front of you. The question is asking, if alpha and beta are the roots of the equation x square minus 2x plus 4 equal to 0, then show that alpha to the power n plus beta to the power n is equal to 2 to the power n plus 1 cos n pi by 3. Okay. So how we will start the question? Let's apply the concept of quadratic equation. What do we know? If ax square plus bx plus c is equal to 0 is a given quadratic equation, then we can find out both the roots by applying the formula x is equal to minus b plus or minus b square minus 4ac root over by 2a. Particularly in this question, x square minus 2x plus 4 is equal to 0. What is my a? A is 1, b is minus 2, c is 4. Now both the roots can be found out. X is equal to minus b, so that is 2, plus or minus b square, so minus 2 whole square, that is 4, minus 4a, that is 1, c is my 4, by 2a, that is here 2 into 1. So I am getting here 2 plus or minus 4 minus 16 root over by 2, that is x is equal to 2 plus or minus 12 root over by 2. I can write 2 plus or minus 12 root over, right? What you can write? Minus 12 root over, can I write here 2 root 3 iota? 2 root 3 iota. Otherwise, you think reverse. If you are doing 2 root 3 iota whole square, that is you will getting 12 iota square, and iota square is minus 1. So minus 12 you will divided by 2. And here we are getting 1 plus or minus root 3 iota. That means we are getting two roots, that is 1 plus root 3 iota, and the other one is 1 minus root 3 iota. So let alpha is equal to 1 plus root 3 iota, beta is equal to 1 minus root 3 iota. Now what we are going to do? We have to find out alpha to the power n plus beta to the power n. But before doing that, let's write the question in some other format. That is, what I am going to do actually here, I am going to apply the de Moivre's formula. So de Moivre's formula, how can we apply? Alpha can be written as, what I can do here, I am going to divide 2 and multiply 2. That means what I am going to do, I have multiplied 2, so that's why I am dividing 2 here. Okay, that means this is something like 2 into 1 by 2 can be written as, okay, if I am going to write it, cos pi by 3, cos 60 is 1 by 2, plus I can write here iota sine 60, that is sine pi by 3. That means this is my alpha. Okay, and from here I can write alpha to the power n. If I am applying the de Moivre's theorem here, okay, so the alpha to the power n will become 2 to the power n cos n pi by 3 plus iota sine n pi by 3. Make it equation 1. Okay, so to understand de Moivre's theorem, you have to go back the previous video, that is exercise 6b part 1. Okay, there I have solved from question number 1 to question number 15, and in between I have given the concept of what is de Moivre's theorem and the related problems we have solved there. Okay, now come to this question. So we have calculated here alpha to the power n. Now let's talk about beta and beta power n. So what is my beta? Beta is 1 minus root 3 iota. Again here you multiply 2 and divide 2. So that is can be written as 1 by 2 minus root 3 by 2 iota. This can be written as 1 by 2. Again I can write cos pi by 3. Okay. This is minus. I can write iota sine pi by 3. Now if you'll see, you cannot apply the de Moivre's theorem here because the structure is not in the format of a cos theta plus iota sin theta. Okay, that means I have to make it cos theta plus iota sin theta format. So what I'm going to do here, I'm going to write here 2 into cos, if I'm writing the cos minus pi by 3 plus iota sine minus pi by 3, then it will be perfect. You will see cos minus pi by 3. So if you are thinking, sir, how can we write cos pi by 3 as cos minus pi by 3? Yes, we can write, because cos theta, if you see, cos theta is same as cos of minus theta. And sir, how you are writing minus iota sin pi by 3 as iota sin minus pi by 3? Because sin minus theta is your minus sin theta. Understood? So here this is my beta. So I can write beta is equal to 2 whole into cos of minus pi by 3 plus iota sine minus pi by 3. Okay, what is beta power n? Again apply de Moivre's theorem. 2 to the power n cos minus n pi by 3 plus iota sine minus n pi by 3. Make it equation number 2. That means from equation 1 I can write alpha to the power n. From equation 2 I got beta power n. So let's prove the question. So in the LHS side of the question we have alpha to the power n plus beta to the power n. That means I can write alpha to the power n as 2 to the power n cos n pi by 3. Okay, plus iota sine n pi by 3 plus beta to the power n can be written as from equation 2 2 to the power n cos minus n pi by 3 plus iota sine minus n pi by 3. This can write as, I can take 2 to the power common, 2 to the power n common, and this is cos n pi by 3 plus iota sin n pi by 3. This cos of minus theta, I have already told you cos of minus theta can be written as cos theta. So I can write cos n pi by 3. This sine of minus theta can be written as minus sine theta. So this will become minus iota sine n pi by 3. Okay. Now you will see iota sine n pi by 3, and here minus iota sine n pi by 3 will get cancelled, and we will be having here 2 to the power n into 2 cos n pi by 3. And if we solve this 2 to the power n into 2, we can get 2 to the power n plus 1 into cos n pi by 3. That is your RHS of the question. So here we have proved our LHS with our RHS. So this is all about your question number 16. Note it down. If you have not still written, go back and pause it, again write it, and try to understand. Come to the question number 17. If you see, question number 17 is asking for a positive integer n, so that 1 plus iota power n plus 1 minus iota power n is equal to 2 to the power n plus 2 by 2 cos n pi by 4. And we have another similar questions in the second bit. Okay, that means if we are solving the first bit and understanding the concept, automatically the second bit will be easy for us. Surprisingly, what I'm going to tell you again, question number 16 and question number 17 are similar. It will be better to say question number 17 is just a part of the question number 16. Okay, let's see how. By looking the question number 17 first bit, what is coming to my mind, that we have to apply the de Moivre's theorem. So some students in class, they used to ask me, sir, how do you know that there will be using de Moivre's theorem? See, I know de Moivre's theorem is used to find out the power of the complex number, and here we have 1 plus iota power n, and here I have 1 minus iota power n. So I have to apply the de Moivre's theorem. But one more concept again, de Moivre's theorem can be applied only if the complex number is in the format of cos theta plus iota sin theta. So let's begin the question. So LHS part can be written as 1 plus iota power n plus 1 minus iota power n. I have to bring this statement in the format of cos theta plus iota sin theta. That's why I can write here. So what I'm going to do, I'm going to multiply root 2 and I'm going to divide root 2. Okay, so this is about the first part. Plus again here I'm going to multiply root 2 and I'm going to divide root 2. Okay, this is the second part of the question. Okay, now this root 2 is here. 1 by root 2 can be written as cos pi by 4 plus iota sin pi by 4 whole power n plus root 2. This is cos pi by 4 minus iota sin pi by 4 whole power n. Now apply the de Moivre's theorem here. So this is something like root 2 power n. This is cos n pi by 4 plus iota sin n pi by 4 plus root 2 power n cos
n pi by 4 minus iota sine n pi by 4. Now bring root 2 power n as common. This will become cos n pi by 4 plus iota sine n pi by 4 plus cos n pi by 4 minus iota sine n pi by 4. And here iota sine n pi by 4 and here minus iota sine n pi by 4 will get cancelled, and this will become root 2 power n already is there, cos n pi by 4 plus cos n pi by 4. This will become 2 into cos n pi by 4. Okay, and now this is something like I can write root 2 power n, that can write as 2 to the power n by 2 into 2 to the power 1 into cos n pi by 4. Now 2 to the power n by 2 plus 1 can be written as n plus 2 by 2 into cos n pi by 4. This is my RHS given in the question. Hence proved. Note it down. Let's go to the second bit of the question. In the second bit of the question, we have LHS as 1 plus iota root 3 power n plus 1 minus iota root 3 power n. So the same story here. Let me divide and multiply 2. So if I am multiplying 2 and dividing 2, that is 1 by 2 plus iota root 3 by 2 whole power n plus, here again I am multiplying 2 dividing 2, that is 1 by 2 minus iota root 3 by 2 whole power n. So this will become 2 to the power n into okay, wait, let me write first of all cos theta plus iota sin theta format. So 2 is there, this 1 by 2 can be written as cos 60, that is cos pi by 3 plus iota sine pi by 3, okay, whole power n plus again 2 into, this can be written as again cos of minus pi by 3 I can write plus iota sine minus pi by 3 whole to the power n. So this can be written as, by applying the De Moivre's theorem, 2 to the power n, this will become cos n pi by 3 plus iota sine n pi by 3 plus this will become 2 to the power n cos minus n pi by 3 plus iota sine minus n pi by 3. Okay, now take common 2 to the power n, this is cos n pi by 3 plus iota sine n pi by 3 plus cos of minus theta, that is cos theta, so cos n pi by 3 sine of minus theta, that is minus sine theta, so minus iota sine n pi by 3. So iota sine n pi by 3, iota sine n pi by 3 will be getting cancelled, and if you see now 2 to the power n into 2 cos n pi by 3. That means this can be written as 2 to the power n plus 1 into cos n pi by 3. That is your RHS of the question. Okay, so hence LHS and RHS got proved. Okay, note it down. Let's move to the question number 18. Before solving question number 18, I will suggest you to watch the video of the complex number 6b part 1, and particularly I am just talking about just before solving the question number 12, you will get the required concept there. Okay, in that clip what I have given there, if x is equal to cos theta, or let's talk out here cos alpha plus iota sin alpha, then 1 by x will become cos alpha minus iota sin alpha. That is, I can write here x plus 1 by x is equal to iota sin alpha and minus iota sin alpha will get cancelled, and I will be getting 2 cos alpha. That means this is same as the given data in the question. Here we have given the data x plus 1 by x is equal to 2 cos alpha. Okay, that means my assumption as x is equal to cos alpha plus iota sin alpha is correct. Okay, this is correct. This is satisfying here, and this also can be written as in the Euler form, that e to the power iota alpha. Okay, so in the same way I can assume, let y is equal to cos beta plus iota sin beta, and automatically y plus 1 by y will become 2 cos beta. So this can be written as e to the power iota beta also. Okay, and here z can also be written as cos gamma plus iota sin gamma, and this is e to the power iota gamma. Okay, so what I'm going to do now, I'm just going to find out x into y into z, that is e to the power iota alpha into e to the power iota beta into e to the power iota gamma. So this will become e to the power iota alpha plus beta plus gamma. Okay, what is 1 by x y z? 1 by x y z will become e to the power minus iota alpha plus beta plus gamma. Okay, so let's talk about the first bit of the question. Okay, here what is there, xyz plus 1 by xyz. So this is I'm just going to start from the RHS side, and in the RHS we have x y z plus 1 by x y z. So this is e to the power iota alpha plus beta plus gamma plus e to the power minus iota alpha plus beta plus gamma. Okay, that means I can write here, this is cos theta, that is cos alpha plus beta plus gamma plus iota sin alpha plus beta plus gamma, again plus this will become cos alpha plus beta plus gamma minus iota sin alpha plus beta plus gamma. So iota sin alpha plus beta plus gamma will get cancelled. So here I will be getting 2 cos alpha plus beta plus gamma, that is the LHS of the first bit of the question. Note it down. Okay, see the second bit of the question. How will you solve? The first 3 to 4 steps are same here. So put the second bit, and as we have already discussed, and that is x as a cos alpha plus iota sin alpha, that is e to iota alpha. So can I write x to the power p is same as e to the power iota alpha p. Okay, again y to the power q can be written as e to the power iota beta q. Z to the power r can be written as e to the power iota gamma r. I have just applied the de Moivre's theorem. Okay, see students, have you analyzed how important is this de Moivre's theorem? Because everywhere we are using that one. Okay, now x to the power p into y to the power q into z to the power r will become e to the power iota alpha p into e to the power iota beta q into e to the power iota gamma r. This will become e to the power iota alpha p plus beta q plus gamma r. This is my x to the power p into y to the power q into z to the power r value. Okay. If I am going to write here 1 by x to the power p, y to the power q, z to the power r, this will become e to the power minus iota alpha p plus beta q plus gamma r. Now let's talk about the RHS part. Okay. That is x to the power p, y to the power q, z to the power r plus 1 by x to the power p, y to the power q, z to the power r. It will become e to the power iota alpha p plus beta q plus gamma r plus e to the power minus iota alpha p beta q gamma r. And after solving this, as we have already done, e to the power iota theta plus e to the power minus iota theta, what will become? The iota part, that is sine part, will get cancelled and we will be getting here 2 into cos alpha p plus beta q plus gamma r. Okay. If you are still confusing how it became, that e to the power iota alpha p plus beta q plus gamma r, you open it as a cos theta plus iota sin theta format में, and this will become cos theta minus iota sin theta format, and this iota sin theta and minus iota sin theta will get cancelled. What is theta? Theta is alpha p beta q r gamma. Okay, so it will get cancelled and you will get the this 2 cos alpha p plus beta q plus r gamma. This is your LHS of the question. Okay, so question number 18 also very easy question, right? So if you are solving one bit, the first bit, the second bit automatically will be done. Okay, note it down. Question number 19. Solve x to the power 9 plus x to the power 5 minus x to the power 4 is equal to 1. So let's start. X to the power 9 plus x to the power 5 minus x to the power 4 minus 1 will become 0. Now take x to the power 5 common. So this will become x to the power 4 plus 1, and if you are taking minus 1 common, this will become x to the power 4 plus 1 is equal to 0. Now x to the power 5 minus 1 into x to the power 4 plus 1 is equal to 0. If you see, we can write x to the power 5 minus 1 is equal to 0, or x to the power 4 is equal to minus 1. Okay. Now, or you can say x to the power plus 1 is equal to 0. The next step will make it. From here I can write x to the power 5 is equal to 1, or x to the power 4 is equal to minus 1. Okay. Here, if you will remember, so for solving this question, I will again tell you to refer the part A, the part 1 of the 6B complex number exercise. If you see, question number 11 was having the similar question. Z to the power 7 is equal to 1, Z to the power 3 is equal to iota, something like this. So let's apply the same concept here also. Let me solve first x to the power 5 is equal to 1. Okay, so how will you do it? X to the power 5 is equal to 1. That means, can I write here x to the power 5 is equal to 1 plus 0? No problem, right? 1 can be written as cos 0. This 0 can be written as iota sine 0, because sine 0 is 0 into iota, that is 0, no issue. But again another thing, when we are solving this type of question, is it necessary to tell that cos 0 is only 1? No. Again, cos 2 pi is 1. Cos of minus 2 pi is also 1. That means, as cos and sine functions are periodic in nature and the period is 2 pi, so I can write, instead of cos 0, I can write cos 0 plus 2n pi plus iota sine 0 plus 2n pi. Okay. What is n? N is any integer. If you put, you will get same as the same value, that is 1. And if you put sine 0 plus 2n pi, whatever the n you put, you will get any integer value, you will get as 0. That means, I can write this is as cos 2n pi plus iota sine 2n pi. Okay, this is my x to the power 5. But what I need actually, I need x, so that's why make it cos 2n pi plus iota sine 2n pi to the power 1 by 5. Apply the de Moivre's theorem. This will become cos 2n pi by 5 plus iota sine 2n pi by 5. Okay, what is n? Right here, where n is equal to 0, 1, 2, 3, 4. Now let's solve. X to the power 4 is equal to minus 1. Okay, so this can be written as x to the power 4 is equal to minus 1 plus 0. Again, minus 1 can be written as cos pi plus iota sine pi. Okay, again the same story. Instead of writing pi, I'll be writing pi plus 2n pi plus iota sine pi plus 2n pi. Okay, and if I'm going to find out x, so I'll take power 1 by 4, that is cos pi plus 2n pi plus iota sine pi plus 2n pi to the power 1 by 4. So this will become cos, this 1 by 4 will multiply with the argument, that is pi plus 2n pi. So this will become pi plus 2n pi by 4 plus iota sine pi plus 2n pi by 4. Okay, and what is your n? Now like right here, where n is equal to 0, 1, 2, 3, because we are going to find out, or we are finding here the roots of the x to the power 4. That means the power is 4, so we will be getting maximum 4 roots. So that is for n equal to 0, 1, n equal to 1, another one, for n equal to 2, another roots, for n equal to 3, the other roots. Okay, so here the question number 19 is completed. Question number 20 is asking, find the general value of theta if cos theta plus iota sin theta whole into cos 2 theta plus iota sin 2 theta. Likewise, it is going on up to cos n theta plus iota sin n theta, and that is equal to 1. So we have to find out the general value of theta. So remember, in the Euler form, you can write cos theta plus iota sin theta is equal to e to the power iota theta. So in the same way, we can write the given series as e to the power iota theta into e to the power iota 2 theta into e to the power iota 3 theta. It is going on e to the power iota n theta is equal to 1. So from here I can write e to the power iota theta plus iota 2 theta plus iota 3 theta up to iota n theta, that is equal to 1, and we can again rewrite e to the iota, take common, so theta plus 2 theta plus 3 theta up to n theta is equal to 1. So now again we can convert it into polar form. So e to the power iota theta can be written as cos theta plus iota sin theta. So here what is my theta? That is, the argument is theta plus 2 theta plus 3 theta up to n theta. So I can write cos theta plus 2 theta plus 3 theta up to n theta plus iota sin theta plus 2 theta up to n theta, that is equal to 1. We can again rewrite it as cos theta plus if I am taking again theta common, here you will be getting 1 plus 2 plus 3 up to n, and here similarly sin, if you are taking theta common, here you will be getting 1 plus 2 plus up to n, that is equal to 1. So this is something like cos 1 plus 2 plus 3 up to n, that is n into n plus 1 by 2. That means I can write theta whole into n into n plus 1 by 2 plus iota sin theta n into n plus 1 by 2 is equal to 1. So now the same thing again can be written as cos theta whole into n plus 1 by 2 plus iota sin theta whole into n plus 1 by 2 is equal to 1 can be written as cos 0 plus iota sin 0. Okay, because cos 0 is 1 and sin 0 is 0, that means this is becoming 1. Again another thing, so not only in case of 0 we are getting 1, again after every 2 pi duration, as the period of the cos and sine is 2 pi, so after every 2 pi again the value will repeat. So instead of telling particularly at 0 we are getting 1, I can write it as cos 2 k pi. Let's go for k because n is already there, so let's go for 2 cos 2 k pi plus iota sine 2 k pi. Okay, so what is k? K is your any integer. Okay, so k belongs to z, you can write what is k, and that is k belongs to z. So what you have to do here, we have to find out the value of theta. That means I can compare the left side of the equation to the right side of the equation, and if you will notice here, this is the concept of equality of two complex number. Okay, and we know two complex numbers are equal if the real part is equal and the imaginary part is equal. That means I can write cos theta n into n plus 1 by 2 is equal to cos 2k pi, and I can write also as sin theta n into n plus 1 by 2 has to be equal to sine 2k pi. So if you are solving the left side part, we will be getting here theta n into n plus 1 by 2 is equal to 2k pi, is imply theta can be written as 4k pi by n into n plus 1. Similarly, this side theta n into n plus 1 by 2 is equal to 2k pi, theta is equal to 4k pi by n into n plus 1. What is k? K belongs to integer, or here also k belongs to integer. And if you notice, we are getting the same value of theta whether we are comparing the imaginary part or real part. So this is our required answer. Note it down. Let's go for the question number 21. Question number 21. If z is equal to x plus iota y, so that modulus of x plus modulus of y less than equal to root 2 into modulus of z. Okay, it's very simple question. Just we have to use some basic formula like a modulus of the complex number and having a plus b whole square formula, and I think you all know. So let's begin the question. What is given actually? Given z is equal to x plus iota y. What is my mod z? Modulus of z will become x square plus y square root over. What will become mod z square? This will become x square plus y square. We know mod x minus mod y whole square is always greater than or equal to 0. Okay, there is no confusion, right? Because if you are taking square of any number, okay, or square of anything, the minimum value will be 0 or it will be positive, but it cannot be negative ever. So in that concept, so something square is always greater than or equal to 0. Now I can open the square. So mod square mod x square plus mod y square minus 2 into mod x into mod y greater than or equal to 0. What I'm going to do here, I'm going to add mod x square plus mod y square both the side. So this is something like mod x square plus mod y square minus 2 mod x mod y plus mod x square plus mod y square greater than or equal to mod x square plus mod y square. What I have done, I have added mod x square plus mod y square both the sides of the inequality. Now you will see here already mod x square plus mod y square is there. So this will become 2 whole into mod x square plus mod y square, and this minus 2 mod x mod y I will take into the right side. So this will become mod x square plus mod y square plus 2 mod x mod y. From the left side I brought it to right hand side. So this will become 2 into mod x square plus mod y square. That can be written as, from here you will see this is mod z square. So this is can be also written as mod x square. X square can be written as mod x square plus mod y square. So I can replace here 2 into mod z square. That is greater than or equal to mod x square plus mod y square plus 2 mod x mod y can be written as mod x plus mod y whole square. And see here. Now take square root to both the sides. We will be getting here root 2 mod z greater than or equal to mod x plus mod y, and this can also be written as mod x plus mod y less than equal to root 2 into mod z. So this is the all about question number 21. Let's move to the question number 22.
Hey guys, are you all doing well? So still now we have solved from the question number 16 to question number 21. Great job. Don't worry, the chapter exercise will finish soon. We have only 8 more questions. Question number 22 to question number 29. Okay, we can do it. Have patience. Take a glass of water. Be relaxed. We'll start from the question number 22. But before that, if you really like the video, then subscribe the channel. If you have not still subscribed, share the video with your friends so that they can also be benefited. Okay, so get back your pen and paper. We'll begin with the question number 22.
Question number 22 is in front of you. Here we have to show real part of z1 z2 is equal to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z2. In the same way, we have to again show imaginary part of z1 into z2 is same as real part of z1 into imaginary part of z2 plus real part of z2 into imaginary part of z1. So how to show this? Let z1 is equal to a plus iota b. z2 is equal to c plus iota d. Now z1 into z2 will become a plus iota b into c plus iota d. So this will become, if you multiply, this will become ac plus a d iota plus b c iota plus bd iota square. So I can write directly here minus bd. I can rewrite it again, AC minus BD plus iota into AD plus BC. So this is your Z1 into Z2. Now, if we'll see here the first part of the question, that is the real part of Z1 into Z2. Okay, what is this? Real part of the Z1 Z2 is our SC minus BD. And this can be written as, what is A? A is the real part of Z1. Exactly. What is C? C is the real part of Z2. Minus, what is B? B is the imaginary part of Z1. And what is D? D is the imaginary part of the Z2. So now the first part of the question has been proved. Let's go to the second part, that is imaginary part of Z1 into Z2. So you will see here imaginary part of Z1 Z2 is AD plus BC. AD plus BC. So what is A? A is the real part of Z1. What is D? D is the imaginary part of the Z2. And what is B? B is the imaginary part of Z1. And what is your C? C is the real part of Z2. And if you see, now the second part of the question has been proved. Okay, so this is about our question number 22. It's a very simple question. This concept we have already discussed in the class actually. If you remember, those who have attended my classes. So in the properties of the complex number, so multiplication of a complex number, in that part we have already done these things. Let's go to question number 23. Question number 23 is a very simple question. See here. What is the value of argument of omega plus argument of omega square? According to the property, we can write argument of omega plus argument of omega square is same as argument of omega into omega square. That is same as argument of omega cube. Okay, and the value of omega cube is 1. Argument of 1 means if I am going to draw it on the argand plane, this is my real axis and this is my imaginary axis, then 1 point, that is the real part is 1 and the imaginary part is 0. So I can have the point something, let this is a z 1 comma 0, and here if you see this complex number z, this line segment making 0 degree with positive real axis, that is our argument. So that's why the argument of 1 or any real number, not only 1, any positive real number, the argument is 0. Okay, note it down. Students, sometimes this argument is also known as our principal argument. So if the question is asking argument or principal argument, the answer will be same. Note it down. Come to the question number 24. In question number 24, the question is asking to prove, but the given things is z1 modulus is less than equal to 1, z2 modulus is less than equal to also 1. Then we have to show. If you remember the first part of our video, that is 6b part 1 exercise, we have solved the question number 1. Okay, I have given the link in the description, you can watch it. The first part of the video is same as to the question number 24 first part. So the question number 1 is same as the first part of the question number 24. That is 1 minus z1 z2 bar modulus square minus z1 minus z2 square is equal to 1 minus z1 square whole into 1 minus z2 modulus square. So nothing to prove it again here. Follow that video, question number 1, you will get the solution. So what we will do here, we will prove the second one or second part of the question number 24. Already we have z1 modulus is less than equal to 1 and z2 modulus is less than equal to 1. That means if I am taking square both the sides, z1 mod square is less than equal to 1 and z2 mod square is less than equal to 1. We can rewrite 1 minus, or I can write z1 mod square minus 1 less than equal to 0 and z2 mod square minus 1 less than equal to 0. That also can be written as 1 minus z1 1 minus z1 mod square is greater than equal to 0 and 1 minus mod z2 square is greater than equal to 0. That is, if you will see, I have already highlighted in the question. From these two data, we can write 1 minus z1 mod square whole into 1 minus z2 mod square will be greater than equal to 0. So if left part of this statement is greater than equal to 0, I can write is imply 1 minus z1 z2 bar modulus whole square minus z1 minus z2 modulus square is greater than equal to 0. Okay, again we can write 1 minus z1 z2 bar mod square greater than or equal to z1 minus z2 mod square. So take square root both the sides. 1 minus z1 z2 bar modulus is greater than or equal to z1 minus z2 modulus. Let's divide. So what we can write, 1 greater than or equal to z1 minus z2 modulus divided by 1 minus z1 z2 bar modulus. That also can be written as z1 minus z2 modulus divided by 1 minus z1 z2 bar modulus is less than or equal to 1. Okay, and here we can write z1 minus z2 by 1 minus z1 z2 bar whole modulus is less than or equal to 1. So if the statement is less than or equal to 1, also we can rewrite z1 minus z2 by 1 minus z1 z2 bar less than 1. So hence our second part of the question number 24 has been proved. Note it down. Question number 25 is in front of you. Interestingly, this question number 25 is similar to your question number 2. If you have solved the question number 2, you can solve the question number 25 easily. Let's see how. The given thing is z1 square plus z2 square plus z3 square minus z1 z2 minus z2 z3 minus z3 z1 is equal to 0. Is imply I can multiply 2, so 2z1 square, 2z2 square, 2z3 square minus 2z1 z2 minus 2z2 3 z3 minus 2 z3 z1 is equal to 0. Again we can segregate and rewrite 2z1 square as z1 square plus z1 square. Okay, I can write z1 square plus z1 square. 2z2 square can be written as z2 square plus another z2 square here. Okay, 2z3 square we can write one z3 square here and another z3 square here. Okay, again we have minus 2z1 z2, so let me write here minus 2z1 z2 minus 2 z2 z3, let me write here minus 2 z2 z3 and minus 2 z3 z1 here, that is equal to 0. And if you see, this part is same as our z2 minus z1 square. Okay, and or we can also write z1 minus z2 square, there is no issue also. Let me write z1 minus z2 square, z1 minus z2 square. This part is something like our z3 minus z1 square, and the third part is something like z2 minus z3 square, that is equal to 0. Let make it simplify. Let a is equal to z1 minus z2, b is equal to z2 minus z3, c is equal to z3 minus z1. Okay, so from this statement, this will become what? A square plus b square plus c square is equal to 0. So we got a conclusion here that a square plus b square plus c square is equal to 0. Next one, you will see a plus b plus c, z1 minus z2 plus z2 minus z3 plus z3 minus z1 also becoming 0. So another statement I am getting here, a plus b plus c is equal to 0. Now this is the time to go back. Go to the part 1 of the video. It's the link is already given in the description, and see the question number 2. The question number 2, it is given if a comma b comma c are complex numbers satisfying a plus b plus c 0. It's already there, right? And a square plus b square plus c square is also 0. Then modulus of a will be same as modulus of b will be same as modulus of c. Okay. That means what is my a? That is z1 minus z2 modulus is same as z2 minus z3 modulus is same as z3 minus z1 modulus. Okay, and this has to be proved, and it has been proved here. Okay, so question number 25 is done. So if you analyze, question number 23 was very easy. Question number 22, if you recall, that has already been solved in question in our class. Question number 24 is same as our question number 1. Question number 25 is same as our question number 2. Okay, so let's move to the question number 26. Just we have only another 4 questions. Okay, question number 26 is there if modulus a less than modulus c, so that there are complex number z satisfying z minus a modulus plus z plus a modulus is equal to 2 into modulus of c. Let z is a complex number, that is x plus iota y. Now z minus a modulus, that can be written as x plus iota y minus a modulus plus x plus iota y plus a modulus is equal to 2 into mod c. Okay, so let me write it as c. This can be written as x minus a, that is the real part, plus iota y modulus plus x plus a plus iota y modulus is equal to 2c. Now we know the modulus concept of the complex number. So modulus of a complex number is the real part square plus imaginary part square root over. That is x minus a whole square plus y square root over plus x plus a whole square plus y square root over is equal to 2c. Now let me rewrite x minus a square plus y square root over is equal to 2c minus x plus a whole square plus y square root over. Now square both the sides, square both the sides. What you will get here, and this will become x minus a whole square, that is x minus a whole square plus y square is equal to 2c square plus x plus a whole square plus y square minus 2 into 2c into x plus a whole square plus y square. Okay, so let's move to the next page. we can again rewrite 4c into root over of x plus a whole square plus y square is equal to 4c square plus x plus a whole square plus y square minus x minus a whole square minus y square. Y square and y square is getting cancelled. So 4c whole into x plus a whole square plus y square is equal to 4c square plus x square plus a square plus 2ax minus, this is x minus a whole square, that is your x square plus a square minus 2x, but I'm multiplying one minus here, so that's why x square minus a square plus 2ax. X square minus x square getting cancelled, a square minus a square getting cancelled. Now this is something like 4c whole into x plus a whole square plus y square is equal to 4c square plus 2x plus 2x, that is a 4x. Okay, so 4 both the sides will get cancelled, so c whole into x plus a whole square plus y square is equal to c square plus ax. Now again square both the sides. Actually here we are not using any logic or any concept, just we are solving the algebraic part of the question. That means this will become c square into x plus a whole square plus y square is equal to c square plus ax whole square. C square into x square plus a square plus 2ax plus y square is equal to c to the power 4 plus a square x square plus 2 c square ax. This imply multiply this c square x square plus c square a square plus 2 a c square x plus y square c is equal to c to the power 4 plus a square x square plus 2c square ax. 2c square ax, 2c square ax will get cancelled, and we have nothing will cancel else, right? So let's move to the next page. Now bring all the x square and y square term to the left hand side. So this is c square x square, and we have c square y square, and in the right hand side we have a square x square, so bring it here. So minus a square x square is equal to c to the power 4 and minus c square a square. Now take x square common, so this is c square minus a square plus c square y square is equal to, if I am taking common here c square, this is c square minus a square. Now let's divide c square into c square minus a square. So divide c square into c square minus a square. Okay, so this will become x square by c square plus y square by c square minus a square is equal to 1. Let c square minus a square is equal to b square. Why? Because it is given mod c is greater than mod a, or mod a is less than mod c, is imply we can write c square greater than a square. So here we can conclude c square minus a square is greater than 0. So that's why I have assumed a positive number b square. Now the above equation can be written as x square by c square plus y square by b square is equal to 1. And students, as we know, this is the equation of the ellipse, right? So this is the equation of the ellipse. So hence you can conclude here that the complex number z satisfies, right? The complex number z satisfies the given equation z minus a. So you can write here. So we can write here. This is the locus. This is a locus of an ellipse, and we can write at last. So the complex number. So the complex number z satisfies z minus a modulus plus z plus a modulus is equal to 2c, where the condition is modulus of a is less than modulus of c. Okay, so don't be afraid, sir. We have solved in 3 pages. The question is much more lengthy, but if you'll see, we have not used a little bit concept. कहीं पे भी आपका दिमाग यूज करना नहीं पड़ा यहाँ पे. So just only the calculus, nothing else. Okay, so let's move to the question number 27. Question number 27. Solve 1 minus iota whole into x plus 3 iota whole divided by 2 plus iota plus 3 plus 2 iota whole into y plus iota by 2 minus iota is equal to minus iota. So the concept is here the application of equality of complex number. That means we'll solve the left hand side and we'll solve the right hand side, and we have to equate the imaginary part with imaginary part and the real part with real part. So let's start. Take LCM 2 plus iota into 2 minus iota. Now multiply this 2 minus iota here. So 1 minus iota into 2 minus iota into x plus 3 iota into 2 minus iota plus multiply here 2 plus iota, that is 3 plus 2 iota into 2 plus iota into y plus iota into 2 plus iota. This is equal to minus iota. Is imply multiply this 1 minus iota into 2 minus iota. So this will become 2 minus iota. So minus 2 iota minus 1 plus iota square, that is minus 1 into x plus this is 3 iota 2 minus iota plus 3 to the 6 plus 3 iota plus 4 iota minus 2, because 2 iota into iota 2 iota square, that is minus 2 into y plus iota into 2 plus iota divided by 2 plus iota into 2 minus iota is equal to minus iota. Now solve the numerator part, that is 2 minus 1. So this is a 1, that is x. This is minus 3 iota x plus 6 iota, and this is minus 3 iota square, that is plus 3 plus 6 minus 2 4, so 4y, 3 iota plus 4 iota 7 iota, so plus 7 iota y plus 2 iota square, that is minus 1 divided by 2 plus iota into 2 minus iota, that is a plus b into a minus b, a square minus b square. So this is 2 square is 4 and a minus iota square, that is plus 1 equal to minus iota. Now you will see here we have x. Let me rewrite the real part and imaginary part separately. So this is x, and we have plus 3, and we have plus 4y, and we have minus 1, the real part. And if I'm taking the imaginary part, I have to common. This is minus 3x plus 6 plus 7y plus 2 is equal to, in the denominator we have 5. So if you multiplying, this is minus 5 iota. Now again simplify this. This can be written as 3 minus 1, that is 2. So I can write x plus 4y plus 2 plus iota into, this is something like minus 3x plus 7y plus 8 is equal to minus 5 iota, or I can write this minus 5 iota as 0 minus 5 iota. Now let's apply the equality of a complex number concept. So two complex numbers are equal if their imaginary part and real part equal respectively. That is x plus 4y plus 2 is equal to 0. This is equation 1. And minus 3x plus 7y plus 8 is equal to minus 5. This is equation number 2. So let's solve this. Let me rewrite the equation 1 into minus 3. So equation 1 will become minus 3x minus 12y minus 6 is equal to 0. Equation 2 is already there. Minus 3x plus 7y plus 8 is equal to minus 5. Now subtract it. This is plus minus minus plus. So this will become minus 19y minus 14 is equal to 5, which imply minus 19y is equal to 19, which imply y is equal to minus 1. And if you are putting the value of y in either of the equation 1 and 2, you will be getting x as 2. So the question was asking to solve where x, y belongs to real number, and this is our required answer. So x is 2 and y equal to minus 1. This is the question number 27. Note it down. Let's move to the question number 28. Students, for solving question number 28, we need some basic concepts. What are the concepts? And the concept is from the topic of cube root of unity. Cube root of unity. We know omega is our minus 1 plus root 3 iota by 2. Omega square, if you take the square of the omega, you will get minus 1 minus root 3 iota by 2. And what else we need? 1 plus omega square will become 0. This is the important one. And the other important concept, not only for this question, omega q is equal to 1. So these are the basic necessary concepts we will apply in the coming question. Okay. So let's start the question. The question is given 1 plus x square power n is equal to p naught plus p1x plus p2x square. Likewise, it is continuing up to p2n x to the power 2n. Okay, and it is asking to prove p0 plus p3 plus p6 plus something it is going on and is equal to, that is 3 to the power n minus 1. Let x is equal to omega. I am assuming. You may feel difficulty, sir, why you are assuming x as omega? See, in the previous concept, I know that 1 plus omega square equal to 0. कहीं ना कहीं मेरे को ये लग रहा है, if I am putting omega, this will be simplifying, right? As in the left hand side, I have 1 plus x square. So if we are putting x as omega, I will be getting 1 plus omega square power n is equal to p naught plus p1 into omega plus p2 into omega square. It is continue up to p2n omega power 2n. As we know, 1 plus omega square equal to 0. So this will become left hand side 0. This is p naught plus p1 into omega plus p2 omega square. The next one is p3 omega q, but instead of writing omega q, I am writing just 1, because as I know already omega q is equal to 1. Next one, p4 omega power 4. So instead of writing omega power 4, I can write omega q into omega. Omega q is 1, so 1 into omega, that is omega. Similarly, p5 omega square, p6 omega q, but no need to write omega q, that is 1. p7 again omega, it will continue. So let's rearrange. So the constant we have p naught, next p3, next p6. In the same way, the omega term we have omega taking common, p1, p4, p7 plus omega square common if I am taking, p2, p5, p8 will continue. Let p naught plus p3 plus p6, this series is equal to capital A. p1 plus p4 plus p7, this is equal to capital B. p2 plus p5 plus p8, this is equal to capital C. So the above equation will become 0 is equal to A plus B omega plus C omega square. So note it down. In the next page, we will start from this equation. We got 0 is equal to A plus B omega plus C omega square. Now 0 is equal to A plus B omega, and omega value you know already, minus 1 plus root 3 iota by 2 plus C omega square, that is minus 1 minus root 3 iota by 2. Now 0 is equal to, we can write A, this is something like I can multiply B, so this will become minus B by 2 plus root 3 B by 2 iota. This is minus C by 2 minus root 3 C by 2 iota is imply 0 can be written as 0 plus 0 iota, no issue. That is equal to A minus B by 2 minus c by 2. This is a real part. And I can take iota common plus iota. This will become root 3 by 2b minus root 3 by 2c. So if you will remember the equality of the complex number, two complex number will be equal if the real part is same as the real part of the other one and the imaginary part is same as the imaginary part of the other one. So here we can write 0 is equal to a minus b by 2 minus c by 2 and 0 is equal to root 3 by 2 b minus root 3 by 2 c. So if we are solving the second part, we can get here b is equal to c. And put this value in the first part. This is 0 is equal to, I can write a minus b by 2 and instead of a c write again b by 2 as b and c both are equal. So this is something like 0 is equal to a minus b. So from here we got a is equal to b. So we are getting a is equal to b is equal to c. Okay. That means we can write, if you remember in the previous page, we have done a, b, c value we have just assumed. So our a was p naught plus p3 plus p6. Likewise, this is same as our p1, that is my b, p1 plus p4 plus p7 like this. That is same as p2 plus p5 plus p8 likewise. Okay, let again x is equal to 1. We have already assumed x as omega and we have solved. So let's again assume x is equal to 1. And if we put in the original question, so this will become 1 plus x square to the power n, that is 1 plus 1 plus 1 power n is equal to p naught plus p1 plus p2 up to it will continue p2n. That means 3 to the power n is equal to p naught plus p1 plus p2 up to p2n. Again 3 to the power n can be written as, if we will separate it or you will make some grouping, that is p naught plus p3 plus p6 one group, and I can write plus p1 plus p4, that is another group, plus p2 plus p5 plus p8 is another group. So we can write 3 to the power n is equal to, that's p0 p3 p6, the addition is same as our a, p1 p4 p7, that is our b, p2 p5 p8, that is our c. So we got 3 to the power n is equal to a plus b plus c. That means we can write 3 to the power n is equal to 3a, because a is equal to b is equal to c. So from here we can find out a is equal to 3 to the power n minus 1. And what is our a? We have assumed a as p0 plus p3 plus p6 is equal to 3 to the power n minus 1. So hence proved. So we'll go for the last question, that is your question of 29. So are you all excited? We are going to finish the 6b exercise fully. Okay, and you know what great achievement you are going to do. Okay, so be ready. Let's move to the question number 29. Question number 29. Now we have two parts. So the first part is given 1 less than z minus 2 iota modulus less than 3. Okay, so let z is equal to x plus iota y. Okay, so this will become 1 less than x plus iota y minus 2 iota modulus less than 3. That is 1 less than, we can write x plus iota taking common y minus 2 modulus less than 3. That means 1 less than, so what is the modulus here? That is the real part square plus imaginary part square root over. So this will become x square plus y minus 2 whole square root over less than 3. So let's do one thing. ये जो root over concept है ना, we don't like this. It is making complicated. So take squaring and this will become 1 less than x square plus y minus 2 whole square less than 3. So we'll break it into two parts. The first part is 1 less than x square plus y minus 2 whole square. That means we can write this is something like, what is actually x square plus y minus 2 whole square? If I'm talking about x square plus y minus 2 whole square is equal to 1. So what do you understand? This can also be written as x square plus y minus 2 whole square greater than 1. So if I'm talking about the equation x square plus y minus 2 whole square is equal to 1. So this will be a circle. This will be a circle. This is x square plus y minus 2 whole square is equal to 1. With what is the center? The center is 0, 2 and the radius is 1. Okay. But here we are just talking about greater than 1. That means outside the circle. So greater than means 1 means what? Outside the circle we are talking about. Okay. Try to understand. The equation of the circle is x square plus y minus 2 whole square is equal to 1. But in the solution we are getting x square plus y minus 2 whole square is greater than 1. So this is the outside portion of the circle. Let's talk about the second part of our solution. We can also rewrite that x square plus y minus 2 whole square less than 3. Okay, see here, from this I am writing. That means this is the equation of the circle. We can assume the equation of the circle with center 0, minus 2 and having radius 3. So radius 3 means it will be something like this, bigger than the previous circle whose radius is 3 unit. But here we don't need the circle because the equation is less than 3, so inside part of the circle. So the required answer is inside part of the circle. Okay. But our actual solution is greater than 1. So the circle greater than 1 and less than 3. Having center 0, 2. That means which is necessary things. So the necessary part is this one. So this middle portion is the required answer. Okay. So this is a region the question is asking in the arrogant plane. Okay. So this blue line is our answer. This is blue region. So this is the first bit of the question. Let's move to the second bit. Note it down. Students, it's looking good, right? Thoda sa colorful. We have used here 4 pens, right? It looks good. Let's move to the second bit. Note it down quickly. See the second bit of the question number 29. Actually here it has been given some hints in your book, you will check. So the hint was argument of x plus iota y will be is equal to pi by 2. इसका मतलब क्या है? हाँ, x is 0 and y greater than 0. That already we know, but still note it down. It is missing in this question. So let's begin. Argument of given is argument of z by z plus iota is equal to pi by 2. That means real part of z by z plus iota is equal to 0, because see here, what is the hint telling? Argument of something is equal to pi by 2 only when the real part is 0. So here the real part of the number is, we can write real part of z by z plus iota, that is equal to 0, and the imaginary part should be greater than 0, that means we can write imaginary part of z by z plus iota greater than 0. So we are going to solve these two equations, that's all. We will get a common answer. This is our motto. Let's solve. Okay, let's solve z by z plus iota. That can be written as x plus iota y by x plus iota y plus iota. That is same as x plus iota y by x plus iota into 1 plus y. And we know, and everyone knows, all SRP knows, that in the denominator iota is not digestible for us. We have allergy, right? So क्या करेंगे यहाँ पे? So we'll multiply the conjugate. That means multiply x minus iota into 1 plus y divided by x minus iota into 1 plus y. So this will become in the numerator, if you are multiplying the x into x, this is x square. This is minus iota into 1 plus y into x plus iota xy. This will become plus y into 1 plus y divided by x square plus 1 plus y whole square. Let's segregate the numerator. This is x square and we have y plus y square. This is the real part, and if you are taking common iota, this is xy minus xy minus x divided by x square plus 1 plus y whole square. And here xy is getting cancelled. That is our z by z plus iota is same as x square plus y plus y square divided by x square plus 1 plus y whole square plus iota into minus x by x square plus 1 plus y whole square. Now let's talk about our equation number 1 and equation number 2. According to equation number 1, that is the real part, equation number 1, that is the real part of z by z plus iota is equal to 0. Is imply, I can say this is my real part. I am making the box. So this is equal to 0, that means the numerator is 0. So x square plus y square is equal to 0. Again, according to the equation number 2, imaginary part of z by z plus iota is greater than 0 is imply, see the imaginary part. So if you see, if I am telling this is greater than 0, see already the denominator is greater than 0 because that is x square plus 1 plus y whole square. So it's already greater than or equal to 0. That means the numerator has to be greater than 0 and minus x is there. So minus x greater than 0. That means can I say x is less than 0. Okay. So these two conclusion we are getting. Let's rewrite it. We can write this is as x square plus y square plus 2 into y into 1 by 2 plus 1 by 2 whole square. See, if I am writing 2 into y into 1 by 2, that is 2 getting cancelled and y is there, no issue. But I have added an extra 1 by 2 whole square. So what I am going to do, I am subtracting this. Okay, so that is equal to 0. Okay, so this is something like x square plus y plus 1 by 2 whole square is equal to, we can write 1 by 2 whole square. So this is something like the equation of, this is the equation of circle whose center is 0 comma minus 1 by 2 and the radius is equal to 1 by 2. So let's draw the circle here. This is a circle whose center is 0 comma minus 1 by 2 and the radius is 1 by 2. Exactly, we're having something like this. So this is my axis, x-axis, this is my y-axis, this is my center. So, and another concept is given that x is less than 0. So finally, if you'll see, we have two things. We have a equation here and this is another equation. So if we take the common part, x less than 0 and the circle. So x less than 0 and circle, you will get only this portion. The left half of the circle is your answer, because in this part only x is less than 0 and the circle. Okay, so this is a region the question is asking for. Okay, so here we finished with our all the question from 16 to 29, and as I have already told you in our previous part, that is part 1, we have solved from question number 1 to question number 15. So hopefully now you are feeling great, because this is a very lengthy unit or exercise, you can tell, but if you are understanding the concept, it's too easy to solve. Of course, I will not tell you that it's easy for you in the first attempt, but if you are practicing at least 2 times the exercise, you will learn a lot of things. Okay, and one more thing, as if you will know that we are all dedicated for the IIT. So why actually I solved this question or this exercise fully here, I felt there is some good concepts and good questions in this chapter which will clear your fundamental, whether you are preparing for the only board exam or for board plus entrance. These questions will help you a lot.
Hey SRPians, you have done a great job. Thank you. You have solved each and every bit question from 1 to 29. That means your 6B exercise is completed. your solution is in your notebook. Okay, go and ask your friends. Believe me, they have not solved a single question of the exercise. So I will be coming with the new videos as per your demand, whatever the solution you require. And again, one more thing here. If you also want any concepts of the chapter, any chapter, okay, so you can put also in the comment box. I will be coming with the solution for you people. So I am here, nothing to worry about the subject. At any time, any help you need, always ready. SRP sir is always ready for you people. Okay. So it's only your duty to study, to ask your doubts, and I am here to solve it. So still then, bye bye. फिर मिलते हैं with a new video.